Okay, so to solve this particular problem, this particular equation, we will observe that this is a quartic equation with whose highest power is 4 as a polynomial with the highest power to be 4. And from this particular equation, we will see that it is somewhat symmetrical. So because it is symmetrical, you will see that the coefficient of this one is 1 here, minus 4, 6, minus 4, 1. So it goes as 1, 4, 6, 4, 1. That's a symmetrical equation. So there is a particular technique you can use to solve any quartic equation that is having symmetrical coefficients. So if the coefficients are symmetrical, that is, we have minus 4 on this side, we have minus 1 on this side, we have 1 on this side, we have 1 on this side. So we can solve such equation using this particular technique that we're about to apply here. So the first thing is we are going to bring this ones, the one with coefficient 1, this one, and the last one, we'll bring them together. This and this, we'll bring them together. So we have x raised to power 4 plus 1, right? So we bring this together. Then we have minus 4x cube and minus 4x. We also bring them together. Then plus 6x squared. So bring those ones two together. Okay. Now what we are going to do here is, this is x to the power 4 plus 1, right? Minus, this is also like 4 4x is common, so that will be 4x minus 4x. So we have x squared left here, right? Minus what is left here? Minus 1, right? X squared minus 1. Okay, plus 6x squared. Okay, now that we have this, we will now divide everything here by x squared. We divide by the coefficient of this one, the coefficient, and that is by this x squared here, rather, not coefficients. So it's gonna be x raised to power 4 plus 1, right? X raised to power 4 plus 1 divided by 2 here, and by x here, by x squared. Then this is 4x into x squared minus 1 divided by x squared, then plus 6x. Sorry, this is supposed to be plus. Then 6x squared all over x squared equals to 0. So what are we trying to do? We're trying to bring out something here. Okay, so if we use this to divide this and this to divide this, we're going to be left with x squared plus 1 all over x squared here. This is 1. Then if we use this to divide this, this is going to cut this, right? And there will only be one x left at the denominator. That x, if it goes into the brackets, it becomes x plus 1 over x, right? Then plus 6 equals to 0, right? Now if we do this, we will observe from here that that is x is equal to, we can now relate this to something we can substitute. We can use substitution method to solve this. So that substitution method that we want to use to solve this, we will say let's m, for instance, equal to x plus 1 all over x, if this is 1 over x. But we observe something, we can write this in terms of this. Okay, so what we observe is that if we say x plus 1 over x, if we square it, we are going to get x squared, right? And if we square this one, that is 1 all over x squared. You square both, then we now use 2 to multiply the 2, right? That is, we'll multiply this and this, that will be 1, then times 2. So we are going to get an expression like this. Now, if we replace this one with m, this is going to be m squared will now be equal to x squared plus 1 all over x squared plus 2, right? So that means x squared plus 1 all over x squared is equal to m squared minus 2, right? So this expression here now is now equal to this. We will now replace this expression here, we'll replace it with m squared minus 2 in this equation. So in this particular equation, let's call it equation 1. So we substitute this in equation 1. Wherever we see x squared plus 1 over x squared, replace it by m squared minus 2. And anywhere we see this, replace it by m. So that way we have been able to substitute. So this is going to be m squared minus 2. M squared minus 2, right? Then this is going to be 4m minus 4m plus 6, right? Minus 4m plus 6 equal to 0. So this is now giving a quadratic equation. So we've been able to simplify this into a quadratic equation. So it's going to be m squared minus 4m minus 2 plus, so that will be plus 4. Right? So now that we have this, we can now use our quadratic factorization method to simplify this further. Okay, so this is going to be, we know that minus 2 and minus 2 will give us minus 4. And if you multiply it, it's going to give us plus 4. So we have m squared minus 2m minus 2m plus 4 is going to be equal to 0. So m is common, bring it out. So we have m minus 2 here, and bring minus 2 out here. This is going to be m minus 2, and that will be equal to 0. So m minus 2 here, and this is going to be m minus 2 equal to 0. Okay, so that means m is equals to 2 twice. So these are equal roots. Okay, m is equals to 2 twice. So it's an equal root expression, and that's because it's symmetrical. But what is that? M is x over x plus 1 over x. M is what? X plus 1 over x. So in that case, is equal to 2. So this will now give us a quadratic expression. So we use that x, which is denominator, to multiply every term there. So it becomes x squared plus 1 is equals to 2x, right? So x squared minus 2x, when it comes here, plus 1 is equal to 0, right? Okay, so we can use minus 1 minus 1 minus x minus x plus 1 to simplify this rather. So this is going to be x into x minus 1, then minus 1, then this is going to be x minus 1, okay, equals to 0. So x minus 1 is common. Bring it out, we have x minus 1. So this is now going to be x will be equal to 1 twice. So you can see x is equal to 1 here from this equation. So in that situation, we say that x is twice. So the final answer of this is just x is equal to 1. 1, 1. We are going to get 4 answers. 1, 1. Because it's going to be on 1, 1, 1. So that's the value of x in this situation.